Hello everyone, this is Mrs. Lindsay. This is problem number 3 on related rates day 2 notes. Alright, so here we have a car that's heading east toward an intersection at a rate of 40 miles per hour. A truck is heading south away from the same intersection at the rate of 60 miles per hour. I'm going to stop right there and draw this scenario. So I'm going to help myself and make a coordinate plane and think about this in terms of north, south, east, and west, because it's talking about a car heading east, and then it's also talking about a truck heading south. Okay, so I'm going to start at this, right? Here's our intersection. The car is heading east towards the intersection. So if they're heading east towards it, they're out here somewhere going in this direction. I'm going to put a C there for car. A truck is heading south away from, again, key words here, towards, away, from the same intersection. So now my truck is going this way. And again, somewhere along that line, it'll eventually be somewhere, so I'll call that T for our truck. Now we do have some other information here in terms of, okay, yes, my car is going at a rate of 40 miles per hour, so let's go ahead and write that down. 40 miles per hour. And again, I'm going to call this C, so that's going to be DC, DT. Then we also have our truck is heading south at a rate of 60 miles per hour. And this is DT, capital T, over DT, lowercase t for time. At what rate is the distance between the car and the truck changing when the car is 8 miles from the intersection and the truck is 15? So that's later information. Let's write that down here. Later. C is 8. And capital T for truck is 15. That's later. Again, both of these are miles. Later information at some point in time. Okay. Well, let's connect what we have going on here. We have our right triangle. Okay. And again, we know these points in times later, but we also know that we have a Pythagorean theorem here. Okay, so I'm going to just call this x. So I'll have c squared, that's what I called this side, plus t squared, capital T squared, equals x squared. Let's go ahead and differentiate. So 2c, dc, dt, lowercase t, plus 2 capital T, dt over dt, again capital T in the numerator, equals 2x, dx dt. And it's that later point in time. Now we can plug in our information. So we have c is 8, and we know dc of dt is 40, plus 2, t is 15, dt is 60, equals 2. Now which of these do we know and do we not know? Well, we're trying to figure out the rate, so that's what we're looking for, dx dt. Well, what is x? And again, remember, now we can plug this in, 8, 15. So you can either use that Pythagorean theorem, or again, hopefully you remember from geometry, your triples is 8, 15, 17. So that is going to be 17. Now it's just a matter of order of operations. On the left-hand side, if I use my calculator, plug that in, I should get 1,160. 2 times 17 is 34. So dx dt is going to be 34.12. And again, this should be, oh, look at that, just in time. in terms of miles per hour. And that concludes number 3 for day 2.